Welcome to The Explainer. Today, we're digging into something that pretty much runs our digital lives, whether it's an instant message that zips across the world or that dreaded loading screen. We're talking about the science of speed.
Come on, you know the feeling. You tap an app, and you wait some more. That little spinning wheel, the loading bar that just refuses to fill up, it's a feeling we all know, right? But have you ever actually stopped to wonder what's going on behind the scenes? Like, why is one app just so fast while another feels like it's dragging its feet through mud?
Well, you might think it's just, the luck of a draw. Some apps are just born fast, some aren't. But here's the thing. The speed of the software you use is never an accident. It is absolutely a science. Every single fast app you love is the result of very deliberate, very specific choices made by the people who built it. See, the speed of your digital life is engineered. And today we're going to pull back the curtain and look at the actual blueprint.
All right, so where does this all start? Well, it begins by thinking about speed not just as a nice-to-have feature, but as a fundamental discipline.
For the people who actually build this stuff, software engineers, thinking about performance isn't something they do at the very end. Nope, it's a foundational skill. It's woven into their education from day one, a core part of how they're taught to tackle problems.
And hey, don't just take my word for it. Here's a quote pulled straight from a university course syllabus. The goal isn't just to teach someone how to write code. It's to give them a comprehensive understanding. And as you're about to see, a massive part of that understanding is all about efficiency.
So let's actually step inside that classroom for a second. The principles that make or break your app's speed, they're taught in this really foundational course, usually called something like data structures and algorithms. And when you look at the syllabus, it's super revealing.
And boom, here it is. Look at this, right there in Module 1. Before they even get to the really hairy stuff, they learn performance analysis. And check out these key phrases: time and space complexity and asymptotic notations. These are literally the building blocks for making software that doesn't make you wait.
Okay, so what on earth do time and space complexity even mean? It sounds complicated, but I promise it's not. Basically, engineers are trained to think about any solution in terms of two super important resources. First, time. That's just asking, how many steps does my code need to take to get this done? And second, space, which is how much memory is this thing going to eat up? Every single piece of code is a balancing act between those two. And how do they talk about this balancing act in a, precise way? That's where this thing called asymptotic notations comes in. Just think of it like the official language of performance. It's a way to describe, with math, how an algorithm is going to behave as the job gets bigger. Like, what happens when it has to handle 10 items versus 10 million items.
But look, theory is one thing. Let's see how this stuff actually moves from the textbook to the real world, how knowledge gets turned into a usable skill.
This is an actual experiment from the lab manual for that course. Students aren't just reading about different ways to sort stuff. They're actually building them, things called bubble sort, quick sort, merge sort. And then they have to compare them scientifically. They have to literally count and measure the number of steps involved. And this is the whole point of performance analysis. It's not about finding one perfect way to do things. It's about having the skill to look at a problem and figure out the best tool for that specific job. So for example, a photo editing app, it probably needs to worry a lot about space so it doesn't crash your phone with huge files. But a stock trading app, it's all about time. It has to be lightning fast. It all depends on what you're trying to do. So when you step back, you realize this training is about so much more than just one course. It's about building a whole new way of thinking. Let's call it the efficiency mindset. And if we look back at the goals of that curriculum, what's the end game? To get students ready for professional work. Because out in the real world of building software, efficiency isn't just some grade on a test. It's a non-negotiable requirement. It's what makes the difference between a product people love and one they delete. So think about it. Every single time you use an app that just feels smooth and fast and reliable, what you're really experiencing is the result of that mindset.
It's the sum of thousands of tiny, invisible decisions made by engineers who were taught to weigh the cost of time versus space with every single line of code they write. Because in the end, the speed of your software isn't magic, it's science. And it's built on a foundation of deliberate, calculated choices. So the next time you fire up your favorite app, just take a second and ask yourself, what are the invisible decisions that are making my digital world faster or slower?